A passive infrared bulkhead light. This was sent for our entertainment by Me-Yack, that's spelt M-I-E-K, Me-Yack, from America, because he bought one of these from eBay, and when it arrived he realised the colours weren't really something he was familiar with, and the instructions were entirely in Chinese and didn't translate terribly well. There's certain elements of English here with helpful phrases like the red is line, black 0, yellow strong line. That's not terribly helpful. And he hazarded some guesses. He's made some notes in the back that black could be live, yellow could be earth, and red could be neutral. The yellow is definitely not earth. And I have to say, in the UK, our old colours used to be red was live, black is neutral, and yellow could easily be construed as earth. It's not a great choice of colour, but I think it's an auxiliary output wire. So let's open this up and see what's inside. So it's modular. We have the LED circle, which isn't actually clamped on terribly well. Is it just because it's got a raised lip? Oh, it might not be too bad. It's got the passive infrared detector module and it's got the LED driver. It's all very modular. And you can actually unplug the cover because the passive infrared module, which is a... Is that just scribbles or is it actually Chinese text on the side of it? Not really sure. But the module is separate to the actual electronics that drive it, the switching stuff. Interesting that there are 4 wires going out to this. I wonder, normally I would expect the sensitive electronics in here to be basically plus 5 volt, 0 volt, and then the signal back, but they're not doing that. I wonder why. We shall find out, because I'll take everything to bits, including taking this thing to bits. I think this just pops out. It does. Oh, this plastic, by the way, things worthy of note. I took a light apart previously and decided, well, I have some of the plastic left over, and I did a flame test on it to see if it would support flame. And it immediately, when the lighter is working, it immediately self-extinguishes. That's quite good. So it is self-extinguishing plastic. It's that type that kind of puffs up. That seems to be part of the action. I noticed this little wave of green there as well. I wonder if there's some sort of boron compound in it. Not sure. Not sure the science of self-extinguishing plastic. But I'm guessing this would probably be the same. I could light it. Hold on. Let's find a little bit at the edge here. This is where the whole thing goes up. It's not even wanting to light at all, is it? This one, however, is not self-extinguishing. Right, so this is not self-extinguishing plastic. Right, it's all gone bubbly but not black and charred. That suddenly made me think about something. You see, they sell these fittings in the UK. Identical. Look at the shape, the little bit of trim round here and so on. So I happen to have one here. So let's get the cover off it. This is a bigger one, and it's notable that the difference here is that the circuit board in here is covered by a plastic sort of vac form to stop people touching it. That's the main difference, and it does have the proper connections marked, embossed in it. Suddenly get the urge to light this. Is it going to self-extinguish? No, it seems to be the same plastic, and it does seem to be supporting combustion. Okay. I thought all stuff like this had to be self-extinguishing, but apparently not. Maybe I'd have to leave it longer, but it didn't look like it was really going out. Anyway, I digress. Much as it's pleasurable to light these things. Now, it's worth mentioning that the module they've used in here, in the style of these typical Chinese fittings, is all modular. You can buy these passive infrared modules on their own just for putting in other fixtures. So it's basically a separate driver, a standard driver, a standard passive infrared module that just clips through that lid, and then this standard LED ring, and you just put them together like Lego. Technically speaking, I could open this one to see what's inside, but we're going to open this one anyway. Let's start opening things. So I'm going to disconnect the LED module, And for those of you wondering why I'm not showing it lit yet, it's because I'm not 100% sure of the wiring either. I think I want to see what's inside here, and then we'll see it lit. Another thing that Miek mentioned was that the driver has the cover on the wrong way around. So the output says input and input says output, but you can kind of tell from the colours of the wires. It's one of those universal boxes that is just kind of made to look like a traditional one with the screws that hold it down, but the screws are actually fake. It's very odd. Let's get the spudger into this. The place smells like melted plastic now. Okay, the driver looks fairly typical. It's a very interesting driver chip. Can you see that driver chip? It's that 8-pin chip. Actual non-surface mount. It's a through-hole chip, but it's got the missing pin for separation. It looks quite interesting. It looks as though it is an isolated transformer by the look of it. It does have a sort of half-assed class-wise pressure capacitor. This capacitor here, the smoothing one, looks bigger than average. It looks bigger than the usual 4.7 microfarad. It's 10 microfarad. Yeah, this looks interesting enough. It looks fairly decent, but it is a fairly standard component. And there's the output diode, the smoothing capacitor, and then that will bulge inevitably, and then a little resistor across it. Okay, so that's straightforward from that aspect. What about the passive infrared module? Let's undo that screw as well and get this large reflective dish out the way. I'll throw all the screws into it. We'll get that down here. Secretly, I'm thinking about that British bought light and thinking, really, should that not be self-extinguishing? Maybe I'm just being overzealous here. Maybe I just have higher expectations. What do we have? We have the cable going into the relay. We've got the feed going to the relay. It could be a two-way switching system here, because the contacts to the relay are here, and this looks like the common, which is actually the live going out to the module. The black is the neutral. It's coming in and it's going straight out to the neutral. So I guess maybe it's kind of a two-way switching-y type system. Not really sure why they've done it that way. I would guess at this point in time, let's just focus down onto there. If this screen hasn't, oh, the screen's frozen. Yeah, that's doing that a lot. I must remember to reset the camera before actually starting. It's time to get a new recording device. Must remember not to do updates on certain products. So continuity, I'm guessing there's going to be continuity between here. There is. So that is a changeover relay, and it's basically the input to the driver is switching between the local feed and the external feed. I'm not quite sure why they're doing that. I would have thought it would be one thing they could do is they could have had the they could have actually had the feeds, this yellow feed connected in parallel with the input to the module, which means that if you chained all the yellows between fixtures in a room, then any one triggering would bring all the other ones on, but that's not what they're doing. That's odd. What do we have in here? We have a capacitive dropper. We have, well, I was going to say it's a BISS 0001, but it's really not a BISS 001. It's a MA8072. I think I've come across that recently. MA8072. I'll have to look that up. I've got the support components, got the transistor that switches the relay, that's fundamentally it, capacitive dropper, the passive infrared detector, and then a relay being switched. You know what? The best thing that can happen to this is this yellow wire could just get chopped off, because then we can actually just use it. So I could put this back together now. Now, interestingly, why have they got 4 connections going out to this? Let's open it and find out what's inside. If this opens easily. I'm guessing it's the little lens that comes out the front to expose what's inside. Oh, I see what it is. I see what it is. They've got the PIR module here, the little thermoelectric detector that detects movement, and they've also got the LDR. That's why there's 4 connections going to it. One is the light sensor. So that cable, technically speaking, would that not make it a bit, given the signal from this little device is quite low, is that going to make it not going to make it susceptible to interference? Don't know. The way the passive infrared detectors work, they have 2 sensors behind this little window, and they detect, they actually generate a small voltage when they detect infrared. So to make sure it only detects movement and ignores the rest of the room, they're wired in reverse series, so like they counteract each other, so that the ambient level of infrared will generally create 0 voltage out. But as soon as you walk past it, you'd create a pattern. If you've got a hotspot walks past, because this polythene lens, which passes, it can be used to shape infrared energy, the polythene. It's one of the few plastics that will allow the infrared through. It acts as a lens, and it has all these dimples that causes a sort of push-pull effect. A hotspot passes, and it creates a sort of hotspot that passes over the surface of this window. And that means that you get a sudden differential between the 2 sensors, and that is enough to trigger a little internal MOSFET, which then gives it local buffering. Although it's a tiny signal, it does provide it basic local buffering before it gets sent back to the chip, and that sort of hopefully reduces sort of noise and interference. But right, let's see if we can put this back on now that I've done that. I think I shall put it on like that. Is that going to go? Yes, it is. Right, tell you what, let's put this back together now. This thing is locked up, right? I'm going to have to try and unlock this, so give me a moment here. And we're back with enough time to investigate the chips. Now, this chip in here, the closest I could find to fit that was an LP8072. Let's just tame this down just a tad. LP8072C PIR controller, and it's not got anywhere near the same pinout as the BISS 0001, which is I think the original purpose of the BISS chips was for not just lighting, but it was also alarm systems. However, this one is optimized for lighting. The most notable feature about it is that it's got 2 outputs, triac output and relay output. The triac output can sync, that means it can pull to the negative rail, 15 milliamps, whereas the relay output, which is just switching a transistor, can source, oh no, it's to drive relay active high sync current 10 milliamps. I wonder why. Oh, it's active high sync current. Why do they call it active high sync current? Anyway, active high output will turn a transistor on, so that you've got a choice of pulling high or low in the output. Detect 0 crossline of AC under remote mode function. That's useful also for controlling the triac, so you get silent switch on. 0 crossing point detection. Because the sine wave passes, it goes positive and then it goes to negative and it crosses through 0. If you're controlling triacs, it's useful to switch on just as it crosses through 0, because it means that you're not going to get a current spike when the triac does switch on. And if you've ever heard that pop from the old radios you used to get, or even some audio systems with sensitive amplifiers, when you click a light switch on, you get a slight pop from the speaker. When you switch at the 0 crossing point, it just reduces that electrical noise, and you don't get clicks and pops out of speakers and radios and things like that. Anything else worth mentioning to this? It's a very vague thing. It does give you some examples. It shows it controlling a triac, a sensitive one, and then it shows it controlling the relay. But other than that, it really is just fundamentally like a standard passive infrared control chip. The driver chip is interesting. It is an LIS 8714D, and it's interesting because it does have that missing pin here. Let's zoom down in this. It's got this missing pin just for separation between the ground and the drain of the MOSFET inside here. It's got the usual current sense resistor. It's got an adjust resistor. Not sure what that's. That might be one for programming the power output, so to speak. And interestingly, it's got the Primary wind of the transformer coupling across the second, just the usual thing. There's a diode capacitor, a little resistor across it, and then the LEDs. That's really common. But here, it's clearly using the back EMF, the sort of the snubber network to actually generate its power supply, because initially the capacitor that powers this chip will charge slowly through these resistors. They cause the slight time delay at power up. But as soon as the circuit starts running, the back EMF spike, instead of just being quenched by this snubber network, it's actually feeding up to the VDD line, the positive rail of the chip. So it self-powers itself from the back EMF spike. It's clever. It's simple. It does the job. It's a neat little chip. The LIS 8714D. And also the fact it's got good decent pin spacing is also nice, because it means there's good separation in the circuit board. It looks actually quite sensibly designed. The reason it's got this double pad for the capacitor here is there's the option to put in a properly sized one. These tiny ones always cast out. This is a Class Y suppression capacitor. I can zoom in this a little bit. It's basically a low value, usually about 1 nanofarad, and it's designed to provide a current path back for current that's capacitively coupled between the windings, because that could cause sort of RF interference. So by providing a route back, it reduces that. But the idea of a Class Y capacitor is that if it fails, it has to fail in a safe state, that if you were touching the output, like say for instance it was a USB charger, if it was to fail, it would fail in the safe state. And they usually do that by just making them a bit larger and having a thicker layer of ceramic inside. But in this case they've not, it's a little tiny one. But they're not really that fussed about it, because usually you won't be touching the output of this, theoretically. So let's say I get this clip back together. I'll even put it round the right way this time. There we go. So that's back together. Let's get the passive infrared detector back together. Now we know that red is effectively the live, which is switching out through, you've got the neutral here, the black and the white, which are common together. So that's the neutral in, and then it's going straight out via this blue wire to the lamp driver. And we get the red, which is the live, which is then being switched through this other wire, which is about the furthest away. And that's probably Ralph calling me. One moment. Yes, that was Ralph announcing his arrival. And now that he's eaten all my chocolate and had lots of coffee, he's away again. So we can continue. So I just finished explaining what wires were for in this. Let's put this back in here and let's assemble the light and check it out. Let's get it working. So I shall lay these wires in here, squish that lid back on again. It's got little 4 indents here which will line up with the wires. And we shall put the whole thing back together again. Alright, so I shall get the wires around the right direction to stuff that out here and then try and work out where did the wires go. So this went somewhere like, this went there. Yeah, it goes there. Let's get the screws, put it back together and then power it up, because, you know, the video wouldn't be complete without powering it up and seeing if it works. It's notable that Me-Yack is based in Orlando, Florida. These screws different sizes, or am I? And as such, he's probably got 110 volt supply, I'm guessing. Oh, these screws are these different lengths, or am I just, right, tell you what, maybe I've just stripped them or something. Maybe they came pre-stripped. Which, this PIR unit says 220 volts. So it's kind of clearly aimed at this Chinesey market. Right, okay, let's try a different screw in that one. Are there different styles here? Not really. Let's just randomly stick another screw and see what happens. This one is slightly tapered. Oh, that's kind of biting better. I'll just pretend it's biting better. Yes, it's fine. And then we've got this one here. Okay, let's put this in here. And get it back together. I'm guessing that many describe this as a sort of paint tin type sort of base. I'm guessing ultimately that they probably come blank and then they punch them. They have a sort of like standardized punch system to shape everything as they desire, you know, whatever they're going to put in. I don't know if it'll come with standardized holes. Let's put this little P-clip in as well. It's raining outside. Hopefully that won't be making too much noise in the microphone. It's just summertime in the Isle of Man. The middle of the Irish Sea involves a bit of sunshine and then explosive rain just to temper it, which is good actually. Round about this time last year there was a bit of a drought going on. It was pretty bad. Right, this looks pretty good. So let's put this connector back into the LEDs. See if I can get it the right way up. Is there a keying? Yes, there is a keying. And the LEDs will probably be all in series. What does this power supply say? Is this the right way up? Yes, it is. The LEDs are actually in parallel pairs. 1, 2, 3, 4, 5, 6, 7, 8 parallel pairs. That's about 24 volts at about probably 200 milliamps, 300 milliamps, 24 to 45. So this power supply can actually drive much larger lights as well. Let's get the lid back in. The one I said earlier. We'll plug this back in. This does, look, it's like, why is it kind of scribbled on? And is that Chinese text scribbled? And it doesn't look like it. Have they just sort of marked it roughly? Oh, I'll tell you what, maybe I should actually pop it through the lid first. That'd be quite good. This slightly scorched lid. I don't know if this is going to just, well, of course it's going to need, yeah, it's going to need the light off to actually operate, isn't it? Right, tell you what, let's get the quick test up. And note that this is not earthed. I have to say, if you're connecting this up, I would recommend getting a little spade terminal or fork terminal. And probably this is the one that's most generous here, running an earth wire up and earthing the metal case if you have an earth facility at your light fitting. I shall plug these wires into the Cliff Quick Test as a very convenient way of making a mains connection. It's a very useful tool in a workshop. So that's that gripped. Plug it in. Close the lid down. Right, I'm not sure what that means. Okay. Is that flashing indicative of something? I don't think the chip's got any sort of intelligence as such. That casts a shadow of the... let's tame this down a little bit. So I'll give you... This is it much dimmer than it actually looks in real life. You can actually see the wiring in here. I suppose there's a risk that people are going to be tempted to open the fitting up and then try and shuffle that wiring. It's notable that the other one, the other fitting I looked at, the sort of Britishy type one, the main difference is that it had that plastic blister across the LEDs to stop people touching it. I guess that's... But this one, certainly the circuit board in this one, not sure what the isolation of the transformer's like, but the isolation looked okay inside it. It looked as though it was a fairly serious power supply, so the output to the LEDs should not be sort of referenced to mains voltage. I suppose ultimately with that liability thing in the UK, they're probably just looking for avoidance of people getting shock anyhow at all. I'm going to have to stay very still if I want this to actually go out because it's detecting any movement at all. And I don't know what the time delay is. I'd guess that it's going to be a fairly long time delay. So the chance of this, even though I'm standing very still, the chance of this cutting off is probably quite slim. Tell you what, I shall tell you how long it runs for by... Oh, no, there it goes. And I move again. It's detecting ambient light. You have to cover it. Okay, right. So that's the duration it operates at. It's quite a long time, which means it's going to probably re-trigger with movement a lot. I'd guess it cuts out the light sensor. Oh, you can actually create little kaleidoscope effects just by screwing with this until it goes bang. Nice. So there we go. I shall pause momentarily, turn the light on, and summarise by saying that if you get one of these, then it's the colour code is the red and the black are the feed If you want an earth wire onto it, which I'd generally recommend for a metal housing, just you're going to have to bring it in yourself and put a little crimp on it and put it under one of these wires. Other than that, I'm guessing it's probably okay. Shall we do a quick hoppy test on it and see what the power consumption is? Let's do that. I think it's supposed to be 12 watts. We shall find out. I shall unplug it. I shall plug the hoppy in here, the flickery hoppy. Is that a built-in function? Does it flash deliberately for some reason? Dunno. Ambient current, because of the capacitive dropper in here, is 37 milliamps, a terrible power factor. Let's do the maths to work out what this would be billed at. And now the dehumidifiers come on. 0.036 times 249 volts at the moment, that's generous, almost 250 volts, quarter of 1,000 volts. Ambient power would be 9 watts if your utility company was measuring for apparent power. But once it actually triggers, can I trigger this? Can I cover it across and... Oh, it's going to require that I turn this off again, isn't it? Nah. Right, let's see if I can trigger it. Oh, that's not terribly helpful, is it? The power consumption is 8 watts. Power factor goes up to a more reasonable 0.5. Yeah. Okay. So that sums that up then. Just white the whole... Yeah, I'll finish just by whiting everything out. Excellent. It's a functional little light, it's fine. One of the better things about these is that you'll usually find these LED rings available as replacements. It's modular. So for those of us who are technically inclined, you can buy the LED driver, you can buy the PIR module, you could just put in a completely different PIR module if you wanted, one with adjustments, and you can change the LED ring to whatever you want. So it's versatile. The plastic is combustible. Yeah, that's not so great, but then so is the one that I bought from a British supplier. I don't know what the regulations are regarding that. Whether, you know, all plastics for light fittings should be self-extinguishing. But I suppose there's not much risk because it is just a little LED fixture. But there we go. Interesting. It was certainly fun taking it to bits and working out the connections and then getting it going.